Okay, so what I've done is brought in that formula for the van der Waals equation, and looks kind of like this, and I'm going to do this for trial 1 and trial 2. Alright, our data is kind of scattered around, but we will work with that. Alright, so for trial 1 I have my pressure, and I had to alright, so here is my trial 1 pressure. I'm adding my correction factor, which is trial 1 moles squared times this constant A, and divided by my volume for trial 1 squared. Okay, so there is my pressure, and that'll work out to atmospheres. If you want to look at that, you see you have moles squared times A. Well, A is liters squared per, or liters squared atmospheres per mole squared, so the mole squared cancels, and then the liters squared cancels when I divide that by the volume squared. Okay, so the units work out to atmospheres. I do the same for trial 2. There's the pressure, now the correction, the moles squared times my constant divided by the volume for trial 2 squared. And now this one is in milliliters, so I'm going to convert that to liters first. Okay, so here we go. This is my van der Waals pressure. We're not done though, because I just broke this down into two parts. Do the pressure part, the volume part, and then we'll calculate the constant from that. Okay, so the volume is for trial 1, we take that volume in liters minus the moles times my constant B. Okay, now here's where we have to again pay attention to our units. Okay, we're in liters and moles. Okay, we have moles times this constant B, but that's cubic centimeters or milliliters per mole. Okay, so what I get here is milliliters, and I'm subtracting those milliliters from liters. Okay, so I need to take this, convert it to liters by dividing by 1,000. Alright, now doing that, I have a proper volume. Okay, here I'm just going to use that volume in milliliters, subtract my moles for trial 2 times the constant B, which is in milliliters. Alright, so this will give me a result in milliliters, this one in liters. So it'll work. We just have to however you calculate, just make sure your units cancel and you know what you're doing. If you write out your units, you can do that. Alright, but you have to pay attention to things like this, where you have cubic centimeters, which is the same as milliliters, so that's not going to cancel with the liters. Okay, and yeah. Alright, so if I want to calculate R, my R is equal to these two, atmospheres times liters, divided by the moles, and divided again by the temperature in Kelvin. And let's see, where was the temperature? I didn't have the temperature written here, so let me go back and find it. For trial 1, I had 294.35. Alright, let's do the same for the next trial. that pressure in atmospheres times the volume, but I need that in liters, so now I'm going to divide it. And then divided by the moles for trial 2, and divided again by the temperature, 295.49.45. Okay, so here is my van der Waals, the constant from the van der Waals equation, 0.04655 for trial 1. And 0.04875. Okay. So now we're going to average it. The two values we got for R. Now this is for the ideal gas equation, not the van der Waals equation. We're going to use for the ideal gas. We average those two values, and let's see, where did I have them? Here are those two values. If I average them, I get 0.04693. Okay, and now I do the same. I want the average for the van der Waals. Well, the average for the van der Waals is 0.04765. Okay, and now I'm done. I have completed the all of the entry. The rest of this will be the instructor assigned grade. Okay. Hopefully this has been helpful. The calculations here, hopefully my disorganization there has not been too confusing. Hope you can follow that.